Cooking? Yep. Okay, so we're going to create a, and I'll actually fill in some of the blanks here as well. I'm going to kind of give you a couple of tips and tricks for, building interfaces relatively easily, and then we'll kind of integrate maybe our soccer game or something like that into the thing. All right, so what I'm going to do here, I'm going to go ahead and close this app. We're going to create a new Android Studio project, and let's call this guy, I don't know, what do we want to call it? What was the soccer game? It's just like a
team roster,
like team manager. Okay, yeah, let's call it team roster. Okay, and yeah, I'll put that in my Dropbox. Okay, so this screen here asks you what kind of device do you want to have this thing on, so it defaults to phone or tablet, and it also chooses the minimum SDK. So for those of you who are Android users, one of the problems with Android, well, I wouldn't say problems, but one of the things we have to take into account with Android is the version of the Android operating system that's running on the device. And you get, Android comes out relatively often, a new update. Well, the devices, depending on the device, doesn't have a great way of updating to the latest, greatest operating system. Some devices do that better than others. So you have this big swath of possible Android iOSs that are running on phones out there, okay? Where on the iPhone side of things, a majority of people are running iOS 10. You probably still have, 10 or 15% that are running iOS 9, and then anything earlier than that's probably negligible, because all their devices kind of auto-update or scream at you until you just update, and then they update, and then it's sluggish, and you have to go buy a new device. That's the Apple way. That's how it works. All right, so kind of what they're having you choose here is what's the minimum SDK that you want to support. And they give you this percentage here of the number of devices that you'll be targeting. So they defaulted it to API 15, which is the ice cream sandwich version of Android. So by choosing that, you'll target 97% of all Android devices out there. And by making this decision, you've also limited yourself to all the stuff that was available during that OS. So any new widgets and things like that have come out since then, you won't be able to use. We're doing simple stuff, so this is fine. So go ahead and hit next. All right, I almost always start with an empty activity. Basic activities are also okay, but I don't like how it layers the layouts, where it gives you two different layouts. Which should they have you do for the tutorial? Basic or empty? Empty? Okay, good. All right, so we'll go with empty activity, and I'll call it... well, we can call it our main activity. That's fine. So, had we previously talked about design patterns in here? All right, let's talk about that a little bit. Wasn't necessarily required, but let me connect a couple of dots for us while we're doing this. All right. Oh, so last thing we talked about in here was recursion, right? Okay. So I've never mentioned this before, design patterns? Okay. I usually will mention it at some point where it's the first time we bump into needing it, but we're going to need it here pretty soon, so this is fine. All right, so how many of you have heard this phrase before, design patterns? Whether you know what it means or not. Okay, it's kind of a buzzy word thing. If you were reading, some website or something like that, or doing some tutorial somewhere, maybe even Code Academy, they might talk about design patterns. So design patterns is kind of a fancy phrase that says a proposed good solution to a, quote, common problem. So I put a couple of things in quotes there because what does it mean for a solution to be good and what does it mean for a solution to be common, right? If I'm a software developer for Lockheed Martin, a common problem I might be solving is fuel efficiency on rockets or something like that, right? That's not necessarily common, all right? So these are proposed good solutions. They're actually great In some ways, this is dysfunctional, but they're great for academics. You've heard the phrase publish or perish before. So academics were supposed to do research and come out with papers, and then you get the little check mark that says, I've been published in some crappy journal somewhere. Design patterns are like the fast food of publications. Because all that's required is you come up with a funky name. All design patterns have to have a funky name. You come up with some problem that's common-ish. You come up with some solution that sort of works. I mean, what's the worst that happens? If somebody else says, well, that's a solution, but it's a crappy solution, and then, oh, you're right, but I still got the publication. Because part of research isn't coming up with ways that work, it's also proposing ways that don't work. Saying, well, this has been tried and proven not to be a good idea. Make sense? Like driving blindfolded, that kind of thing. You know, at some point, somebody decided, well, can I do it completely based on hearing? And it probably just didn't work out. You know, but it was an interesting question to ask at some point. Unless you're that guy from Daredevil, right? Yeah, the show. I bet you he could drive, right? I mean, that guy's amazing, right?
I'll never watch the first season.
Oh, really? Yeah, actually, I think I'm only like maybe a third of the way through the second season. Because I got into, I think that was the same time I started watching, was it just Marvel's Jessica Jones? That was pretty good. Now I need to see the new one. Jessica Jones' boyfriend. What's his name? Luke Cage. Has anybody seen that? Is it good?
Yeah.
It's good? Yeah, all the Marvel things have been at least, on Netflix, have been at least pretty, none of them have sucked yet. Some of them are better than others, but they all seem to be somewhat binge-worthy. Okay. So design pattern is just a proposed good solution to a common problem. Whatever that means. Okay? Now, we do have a couple of popular design patterns. So one of these guys is called MVC. Model View Controller. I'm guessing in the tutorial you'll saw that mentioned at some point. Did they mention that in the tutorial? Model View Controller at some point?
I don't know, but we did do this in 200.
Okay, so you've seen this before?
Yeah.
All right, so you lost that word, the phrase model, you lost the phrase design pattern. All right, so we have this thing called a model view controller. But do you remember what model view controller was? All right, so model view controller says it's a good idea to separate your logic from your interface. And really, I can throw in little parentheses, and your database. So really, there's three pieces. You know, you have your data in one place, you have your logic in another place, you have your interface in another place. But we haven't really touched the database stuff yet, so we're just going to pretend like that doesn't exist right now. But it's a good practice to keep those things separate. Okay. Now, if you remember back where I probably brought it up, I'm guessing, in 200s when we talked about PHP, when we talked about the evolution of those web languages.
MVC was on the final.
Okay, yeah. Yeah. This is evidence of education, right? You study enough to get through the final and then out the window, right?
It's like, now that you say it, I know exactly.
Yeah. I mean, but that's not necessarily, I mean, it's easy for a teacher to stand up here and say, whoa, you should have learned this stuff. But I mean, I didn't go, you know, when you're in these math classes, you learn the tricks to get through the math class. I didn't actually learn some of the important math stuff until I was in grad school when I actually realized I needed it. Like I was in an artificial intelligence class and all of a sudden, it's like, oh, I need to know a deeper knowledge of integration, how integrals work. This whole area under the curve thing, well, whatever that means. But, you know, all I learned was a handful of tricks that got me through the exams, right, in undergrad. Now that whole area under the curve starts playing into artificial intelligence in terms of learning patterns. And yeah, so I had to go back and relearn all that stuff. So it was... I know where you're all coming from. Is what I'm getting at. From a professor, I don't agree with it. From a human being and a former student, I get it. Well, I guess not even former student. We're all students for life, right? Okay, so model view controller says it's a good idea to separate your logic from your interface as well as your database. I brought it up probably when I was talking about PHP, some of the evolution of our web languages. And PHP, even though it's still around today, one of the early problems it had is as websites started getting more and more complex, what PHP is, it's effectively an HTML document whose name is .php instead of .html. and you have HTML as well as PHP syntax meshed together. They're all inside of one document. All right. Anybody remember the term that refers to that the .phps instead of the .html? It's called a MIME type. MIME type. So when it notices the MIME type of .php, it knows it has to go and do something special with that file rather than just send it to the web browser. Similar, when you double click on a .doc or .docx file on your computer, it knows to open up Word because its MIME type is of type application Word. All right. So in any case, Model View Controller was this idea presented that started saying, you know, as our websites get bigger and bigger and bigger, this document, this PHP document that has a whole bunch of HTML in it, the interface, as well as a whole bunch of logic, the PHP code, meshed together is starting to become unwieldy. It's hard to, debug this. It's hard to add stuff to it because it's just this mess of code. So let's separate those two and have them work separately from each other, and then in some convenient way allow them to communicate with each other. So we can focus on the pretty look and feel over here, and we can focus on it working over here, and then make those guys talk. Make sense? All right. Now, it would have been easy to say that PHP would have died off because of that, but what you end up having is a rise of third-party applications that ended up making life easier for PHP. So that's why it's still around. You know, it's still fairly popular today because we've fixed the Model View Controller problem. Very few people would actually write, unless they're doing a very simple, tiny site, would actually write PHP code inside of an HTML document today. All right, so Model View Controller says we should keep these guys separate. All right, so when we go back here, notice it's creating an activity. So this is my Java file, main activity.java, and this is my layout, my interface. So activity underscore main is going to be an XML document. That's just how Android represents their interfaces. And the Java file will be main activity. So we have our logic and our interface in two separate places. Make sense? So this is Android's version of MVC. All right, I'll go ahead and hit finish. It's creating my project for me. Oh, and anyway, so you basically said that that second tutorial you didn't even know what you were supposed to submit. Yeah, I mean, I was coughing all over the place. I just looked for something to give you. Okay, just as long as you submitted something that looks reasonable, I'll just give you 100. I was just too sick to come in. It wasn't going to happen. Maybe what I wanted you to get out of that above anything else is the whole idea of fragmentation in Android, where you have a whole bunch of different devices with different screen sizes and stuff like that. So sometimes it might be beneficial to rate multiple versions of your interface for different screen sizes. That makes sense? Now, having said that, a normal interface will kind of try to resize itself. So if you write a single interface and run it on 5 different screen sizes, it will do its best to look similar on those different screen sizes. I'll show you a couple of tricks to that today. The times when you would probably want to have more than one interface is when you have a very intricate or a very kind of advanced interface that needs to act a very specific way. Then it might be worth your extra time to do that for the multiple device sizes rather than have it self-adapt. Okay. All right, so here's our main activity Java code. Here is our interface. Let me... Why did that guy not pop up as a designable thing? So here's our application over here. So under our resource folder is all of our layouts and things like that. So here's our activity main. If I double click on that guy, yeah, that's what I was looking for. I don't know why it didn't open it up like that to begin with. It's yelling about a couple of things. Let's build the project and see if that stops screaming. But if not, we'll move on with life. All right, so over here on our activity, I'll explain this and then we'll go back to that. I've in the past mentioned that all programs begin and end with main. Okay, that's still true in this. So if we started investigating into this whole Java library here for all the different, the actual Android subsystem that lives below this, we would eventually find a main method. And that main method would do maybe some interesting stuff and then ultimately launch our initial activity, which in our case here is main activity. So the main method does exist. We just don't directly interact with it as an Android programmer. So assuming we have a single activity Android application, so an activity is a screen in our application. So if you have an application with 3 screens, you'd have 3 activities. All right. It actually can get a little bit more complex on that with something called fragments, but for right now, let's just leave it at what I said. So an activity equals 1 screen in your application. So our first opportunity to interact with that screen, our version of main, if you will, is this onCreate guy. So when this screen is first created, now we can start doing stuff. Okay? Now, this is the first time we see MVC in action here. So I'm going to actually update this a little bit. I'm going to say, do not belong to the project. Okay. It's weird. Okay, so I'm going to say this dot right here. So this dot refers to this particular activity. So this particular activity is going to set his content view, what we see. So this is the Java side of things. He's going to set his content view equal to our activity main layout. That's where we're marrying the code to that interface in terms of what this activity should, the mask the activity should wear and show the world that's viewing it. All right. So this line of code right here is the line of code that actually starts that MVC process. Okay. Let's see here. Refresh the layout. It's very strange. Let me kill Android Studio and just relaunch it. Okay, seems like we did a little bit better that time. All right, let me do a couple of things here. Okay, and actually I can... So this guy over here kind of gives you a visual view of the widgets that you're using as opposed to kind of a WYSIWYG view right here. I rarely will use this guy over here. So here's kind of our widgets that we can drop in to our activity. This is the view side of MVC, what we're messing with here. This is our actual interface. Now, let's say 75% of the time you can accomplish what you want to accomplish by just dragging things in here. And let's see, let me get something in here. Where's the... I want to get to the view I'm looking for here. There's a list that you can get out of this. That's not it. That'll show you kind of the way these guys are embedded. It's who? Oh no, that actually shows you the XML code. So this is where you would go if all else fails. But there is a view over here that will show you kind of that you have a relative view, and then inside of that relative view you have a text view, so you can kind of drag the guys around. Let me see if I can find that here real quick. Oh, that's the design and blueprint. What's this guy? This is just the design. Okay. So I prefer that anyways, unless the blueprint has replaced. I guess it's possible the blueprint's replaced what I'm talking about. No. Oh well, we'll see if it pops up at some point if I accidentally click on something. What I'm referencing is there usually, well, I say usually, there is something that appears over here that kind of gives you a look similar to this here. You know, where it'll show that we have our relative view right here, then inside of that we'll have a text view, and then I can drag these things around to more granularly move between stuff. It's possible they've taken it out, replaced it with that blueprint thing, I guess. So we'll just keep trucking, unless, does that give me maybe more space? Oh, whatever. Okay, so as I'm doing stuff in here, I can, and the default here is relative layout, which I rarely will use. So I'll replace it with something else here in a few minutes. But this is just your simple Hello World program. So when you're ready to go, you can just hit play. If you don't have a device already built, you can create a new virtual device. The tutorial probably took you through that, right? So I'm using a Nexus 5 API 21, which is, remember we chose API 17. So I'm running a fake device here that's actually running a newer version of Android, but that should be backwards compatible with older versions because I'm not using any of the newer widgets. So this should be fine. And I'll say use the same device for future launches. So we'll hit OK. It's going to go ahead and launch my emulator. Okay, so now for some of you, this launching of the emulator should have happened pretty quickly. For others, it took a week-ish. It's fairly quick on this. It all comes down, that's an Intel technology. So if you have an Intel processor and you have Haxum installed, it uses your processor itself to increase the speed of the emulation. So rather than Android running 100% virtually as a piece of software, it actually pretends your Intel processor is the core processor in your Android device and runs substantially more quickly. Okay, so that's the, otherwise you have to deal with the old Android stuff. So there's our Hello World application loaded there. Makes sense? All right, so now for those of you who do have AMD processors, I haven't actually done this. I don't have any machines with an AMD processor, but I know students who've done this before. Some people have referenced that there's some setting in the BIOS that they can change that makes the that will make it Haxum all of a sudden be compatible. I don't know what that setting is, but something for you to investigate if you want. Otherwise, what I typically tell them is just once you get the emulator launched, just don't close it. Just leave it open on your computer so you don't have to wait the 20 minutes for it to launch. Once it's launched, it should work relatively reasonably. It might be a little bit sluggish, but that's not the problem. The problem is the launch time is a month. Well, it's kind of like Chicago traffic. Yeah. You might luck out, probably not. Right? It's that. All right. So there's our simple Hello World program. Now let me zoom in here. Now, what I'm going to go ahead and do, I'm going to get rid of this label here. Now, the default for this original guy, if I go to the text version of this, notice that everything here lives inside of this relative layout. I will either replace that, typically, or I'll immediately put a linear layout in there. Especially for kind of business applications, we have two different layouts that are kind of our go-to moves. We have horizontal linear layouts and vertical linear layouts. And what these linear layouts do is anything we throw into it. So think of these like a bucket, a self-organizing bucket. So if I have a vertical linear layout and I throw a label into it, it's going to go to the very top of that guy and then drop down as far as it can go until there's not a widget, and that's where it goes. It's vertical. And I can just keep throwing labels in there, and it'll just keep stacking them on top of each other. That make sense? So it's self-organizing, so it makes the thing look the way you want it to look. So if you use a series of vertical linear layouts and horizontal linear layouts, you can kind of build your interface as a grid. Okay? You lose a little bit of granular control by doing that because kind of everything has to be the same size and they're all squeezed together, this kind of stuff. But with some tricks, you can build simple interfaces relatively quickly using just linear layouts. Relative layouts now start moving into stuff where you're placing things relative to other things. So if we go back here, I'll go ahead and throw a text view back in here. So, I'll drop that there, let's say, and now I'll take another text view, and notice as I'm dropping it, it's kind of showing me arrows where it would live relative to the previous guy. Does that make sense? So relative gives me, so notice it's like kind of drawing that this thing is down so many pixels, over so many pixels, and a relative angle to the guy at a certain level. So this gives you a lot of granular control of where you want to put something on the screen. And then, if you run this, so we have a couple of text boxes. Go ahead and hit play here. And this is a relative newer thing. It's been around for maybe 8 months or so, this instant run. So rather than relaunching your entire application, it just updates the current screen with the new interface. So let me hop over to that. So here's that relative layout here. Now, the danger with the relative layout, even though it seemed to be nice and convenient, is for any interface that's going to be somewhat complex, this guy's going to probably back you into the corner of having to write your interface for multiple devices, having to have multiple interfaces. Because imagine if this was a much smaller screen size, and I said I wanted this label this many pixels down, this many pixels over from this guy. Well, all of a sudden, if I have a skinnier screen, this dude might be off the screen. Does that make sense? Whereas if you're working with linear and vertical layouts, everything just sucks to where it needs to go, and your limitations are the walls. So as if you have 5 things in a row horizontally, and you go to a very small screen size, it's just going to smush those guys close together. You might get to the point where maybe you change your interface, you don't have 5 things right next to each other because that doesn't look right, but it'll still do everything it can to keep everything on the screen. Make sense? So kind of a trade-off. I almost always use linear layouts, but I'm also not a designer, so I typically will create fairly simple interfaces. So the very first thing I'm going to do here is I'm going to go down to my layouts, and here's this is a horizontal, here's a vertical linear layout. I'm just going to drag that guy in there. All right, and I'm just going to go ahead and stretch it all the way to the top. So that takes up my whole screen. So now my new bucket is a linear layout. Now if I wanted to, I can go in here and I can steal a couple of these lines. And, oh, maybe this is the, no, it doesn't let you do it. I could steal a couple of these lines and make this guy my parent layout instead of a linear layout being inside of a relative layout, but it's not really hurting anything. If I never touch the relative layout again, I just have everything inside of my linear layout, life will be fine. Okay, so this guy is a vertical linear layout, which means that as I drop widgets in there, so here I'll drop a text view in this guy, I'll drop another text view into this guy, I'll drop another text view in this guy, it automatically just stacks them on top of each other. Make sense? All right. Now I can go ahead and I can similarly, let's actually, I'm going to come in here, I'm going to dump those 3 text views. Sometimes it's easier just to do it in the XML there. Now remember, XML we had introduced this last semester as well, I'm sure, in that same conversation. We were talking about the difference between normal programming languages and data representation languages. XML is kind of like HTML in that it's this tag-based language, but HTML is specific for making web pages. This is a XML-based language that Google has introduced for describing their user interfaces. Okay? So inside of this vertical linear layout, I'm going to go ahead and put a horizontal linear layout. Where's my layouts? Here. Oh, this is what I was looking for. This component tree thing. They just moved it on the sides for me. All right, so you'll see what I mean here in a second. All right, so I'm going to go ahead. Yeah, this guy's really important. Where's my... I need new eyes. Even when I'm not sick, I need new eyes. All right, so there's my horizontal layout. We don't really see anything in there. The guy's sitting here kind of at the top, somewhere in there. You can see that here's our vertical layout, and inside of that is our horizontal layout. Right? So now what I'm going to do is I'm going to go ahead and I'm going to drop a couple of text boxes in here. Notice it put those guys inside each other. But let's say I wanted one of those text boxes. Here, I'll drop another one in there. Or a label. Okay, so there's my 3 labels. Okay, and let's say they're in the wrong order. Let's say I actually want this label to be above that guy, and so you can manipulate them more easily by dragging things around over here rather than trying to click things here. But let's say I want this last label actually not to be inside of the horizontal layout, but instead be inside of the vertical layout below the horizontal layout. I can grab this guy, and let's see. Might be easiest for me to drag him there, then do this, then drag him there. All right, so now I've moved that guy outside of my linear layout, my horizontal linear layout, but inside the vertical one. But now notice my linear layout is huge right now. It's taking up the whole screen. So I might drag that guy up there to be a different size, or what I can do is I can go to the properties of this guy. So when we talk about layout width and layout height, we want to give some meaning to these guys. So layout width, it currently says match parent. So the parent of this linear layout, this horizontal linear layout, is the vertical linear layout in which he lives in, right? That's his parent. The parent of the vertical linear layout is the relative linear layout. So if I click on the vertical one, you'll see his width also matches his parent. And the parent, the relative, matches the device width. Okay? So this internal horizontal linear layout, his width is going to match the parent. We want it to go all the way across. Makes sense. Fine. But the layout height, I have also matching the parent. What we really want that to do is wrap the content. Wrap those boxes that are in there. Make sense? So now that guy's become significantly more reasonable in size. We could have also drug it to be a different size, and then that would have become pixels as opposed to relative to other things. Pixels are always dangerous in interfaces unless you have a button, you just want that button to be 25 by 25 on all devices. The problem with that more often than not is if you have a smaller screen, a button that's 25 pixels by 25 pixels might be reasonably sized. If you have one of these giant phones, that 25 by 25 pixel button might be almost unhittable. It might be too tiny. Okay? So, you get a phone like this, it might not work. A lot of people think this is a 6 or a 7, not a plus, but I'm giant. So this is the big phone, actually. Things are it'll look smaller on there. So you might want to have a relative size. Maybe maintain an aspect ratio and let the thing go ahead and stretch out depending on the different screen size, but just maintain that 1-to-1 aspect ratio, that kind of stuff. But these are things you can experiment with. We are not going to focus greatly in here on pretty interfaces. In fact, I say greatly, almost non-existent. Most of you are going to be more artistic than I am. It's not my strong point whatsoever. If you want your interfaces to look nice, you can spend your time on it. All I'll be looking for in homework assignments is just some sort of reasonable interface that shows me the output of your program. Okay? But you'll get used to working with the widgets, and then you'll take it from there and decide I'm going to get interesting with it. Make sense? Okay, so if you turn in an interface that looks like complete crap, you're not losing points. I only care about the logic, but this is a skill set that will benefit you in industry, right? And also a skill set that can benefit your pocket while you're in school. Because, after you do this stuff, there's nothing that says you can't start writing apps and putting them up on the App Store. And the information you learn here is directly transferable over to writing stuff for iOS. There's a little bit of a learning curve learning Swift versus Java, but they look pretty similar. The iOS ecosystem for writing this stuff is better than this. So I think what you'll end up finding is as you're learning how Xcode works writing this stuff, you'll say, oh, well, this was so much worse on Android for about 9 out of 10 things. And then every now and then you'll run into something like, oh my gosh, this would have been so easy in Android. When you're just trying to get something real minuscule to work in iOS. So, because one of the things I've mentioned to you is when I'm doing Android applications, I tend to shy away from a relative layout. That's a personal opinion. Notice that the default is a relative layout, which probably means that a lot of folks use relative layouts as their base. I don't. I feel that I produce less offensive looking interfaces using linear layouts than I do with relative layouts. Personal preference. On iOS, all your layouts are relative. But you never have an opportunity to work with the text here. iOS's interface builder is much better when you drop stuff in and you just place it, and it's just a better design. And part of that has come out of what we're using here, this Android Studio, used to be a plugin. Android used to be a plugin for Eclipse. So you're really taking the programming product that is Eclipse, and you're attaching a plugin that gives you this interface design wizard thing here. And now they just said, okay, well, we're going to take the open source product Eclipse, we're going to build in our interface wizard, and now we're going to call that guy Android Studio. It's still two separate products connected to each other as opposed to something that was built as one single ecosystem. One's not necessarily horrible versus the other one, just that's why you get some clunkiness on one side versus the other. Okay. Similar here, I can adjust now the height of this guy to match up. He didn't auto fix himself, but because he was already pushed out of position. But you start getting used to how this stuff might end up working. Make some sense? Okay, so there's a couple of my things there. Now let's say, so these guys are, well actually that's an edit text, so that'll be a text box. I'm going to get rid of that, and let's put a text view in there. So there's my text view, and I'm going to make that guy a little bit, well actually let's do this. View all properties. So I'm going to show you some properties here that we can do. Oh, actually, I just want to get one that has a larger text by default. Those are edit text. Oh, whatever. There's a way to increase the text of the font of that guy pretty quickly. There's font family. Maybe is it called text size? Text color, text size. All right, so let's make this guy, I don't know, 28 or something like that. $24, there, bigger text. All right, so now that guy has text size 24. Now let's say we wanted this guy to be centered. We wanted the text to be centered on the screen. Now, this is one thing that I actually like better on Android than I do on iOS. Every single thing we see on the screen is a view. Okay? Even though relative layouts and linear layouts are kind of invisible, we don't officially see them, but we know they're on the screen because they're organizing structures, right? All of these things ultimately inherit from a view. Okay, so something we're kind of getting ready to start talking about on the Java side of things is this idea of inheritance. And we've referenced it a couple of times. So, for instance, we might have in our soccer game, we might have the idea of a human. And then some humans are players. Some players are specifically soccer players. That kind of thing. So we might write a class called human that tries to capture things that every single generic human has. We all have a name, we have an eye color, we have a hair color, we have a height, that kind of stuff. Things that are common to all human beings. Okay? Then you have players. So now we kind of picked a couple of things that differentiate an athlete. Maybe instead of player, we call these guys athletes. Did I spell that right? It doesn't look right. It must be right. It doesn't look right. It's like weird, isn't it? It's one of those words. So now we decide, okay, well, what things differentiate athletes from normal humans? So, we might just decide to put in a couple of statistics about, endurance and stuff like that. Things that become important as you're an athlete that we don't really think about what your endurance is just existing, right? So we'll just force that issue. Now we have this idea of a soccer player. Well, what makes a soccer player, different than an athlete? Okay, well, a soccer player, he's going to have, a cleat size. He's going to have, maybe number of goals, that kind of stuff. Some statistics that make him a soccer player. So object-oriented programming is going to say that it's in our best interest to divide our objects like this, so that we don't duplicate too much code. So we'll define a generic human, then we'll define an athlete, then we'll define a soccer player. And we'll define a soccer player in terms of an athlete, in terms of a human. So we borrow, so this would be the child object, this would be his parent, this would be his parent. All right, so this will, I'm just kind of going ahead here because we haven't introduced this on the Java side of things, but this is going to introduce a new keyword for us called super. We've introduced the this keyword. This is how an object refers to itself from within itself. The super keyword is how a object refers to its parent. That make sense? Okay, the super keyword is how an object refers to its parent. All right. You okay? Oh. Like headache or something, or like medical emergency? You don't know yet. All right, well, let me know if something bad starts happening. You go try to rinse them out? Okay, well, keep me updated. Okay, so we have our soccer players, we have our athletes, we have our humans. This is inheritance. So from a soccer player's perspective, his parent would be the instance of athlete that was created to support him. We reference that instance of athlete using the keyword super. Okay, so this is how a soccer player would refer to himself. Super is how a soccer player would refer to the instance of his parent, which is athlete. All right, so this gives us a couple of ways of referencing this inheritance thing. All right, so right here, so all these things that we see on the screen are views. At their basic level, they're views similar to how all athletes are humans, all soccer players are athletes, which are also humans. So this guy might be a button, which is, an edit view, which is a view. Something like that. Okay? So all views in Android have something built into them called gravity. And actually, I think this is a pretty cool design because it's sometimes this is something that's difficult to pull off. The trivial stuff I'm going to do right here is easy to do in iPhone, but every now and then there's something you want to pull off on iPhone that just isn't there because there isn't a generic construct like gravity that we have in Android. So every single view, so for instance, right now I have a text view highlighted. This guy has his own gravity. So what you need to do is you need to think about if you lived in the environment inside that text view. you're experiencing the gravity of that text view. And we can adjust that gravity. So I have that guy highlighted. I'm going to go down here to gravity. And we can choose the gravitational forces that we want to occur inside there. So we can, the thing's already the smallest size it can be, so that's not going to, so if I want to change the gravity to right, that sucks everything to the right of the screen. Okay? If I want to center it horizontally, well, here's a center. The centers it horizontally and vertically. Okay? So now, that text view, that text that's in there is like us being inside of that view. The gravity just sucks us to the center because of the gravity of that view. Does that make sense? All right, so, but we can deal with this at other levels as well. So we can, for instance, take our linear layout here. This is our horizontal linear layout. And we can adjust his gravity. Let's say we make his gravity center. Now, notice that the text inside of here did not change. The individual dudes that live within there, so this is, what are these guys? Are these text views or these edit texts? Okay, these two, this is an edit text and this is an edit text. So think of this as two people living inside of this environment right here. The environment right there is a center gravity environment. So those two guys are centered the best they can. We happen to be living inside of an environment that has a structure of lay everything out horizontally. That's why we're not seeing them move. But the important thing is it doesn't mess with the insides of these guys. All right? So you can have things centered within one view without impacting the contents of those views. Okay. So let's go back. I'll just take the centering off of that. Where is... Do I not have it? Oh. Where is my gravity? That's weird. So I just took gravity off there. It wasn't hurting anything, but whatever. Okay, so gravity kind of makes some sense. All right, so now what we want to do is we want to have some control. So now we're back to this idea of MVC. So we've already seen that over here on the Java side of things, this is how we say that this particular code side of this activity sets the activity main, the entire layout file, as his costume, as his mask to the outside world. That's the view for the entire thing, okay? Now, back here, what if I want to adjust the text that lives inside of this text view? I need to have more granular control of the individual components that are in that layout, right? So I'm going to go ahead, I'm going to double click on this guy, and it's going to give me kind of the high, these are, let's call this the important properties of the commonly used properties of this text view. And one of them up here is his ID. So I'm going to call this guy title TV. This is going to be our title text view. For whatever, I want to set some text and I want to call this guy the title. So I'm giving this guy kind of a variable name. Okay, that way I can easily find him when I'm searching for him over on the code side of things. Because text view 8 doesn't do me a whole lot of good, right? So we're going to name that guy something reasonable. All right, this is the text that's currently in there. We're just going to leave that alone for right now because we're going to change that. All right, so this guy's ID is title TV. That's a way of us uniquely identifying this guy. All right, so now what I'm going to do is we're going to go back to our code here. And I'm going to go ahead and I'm going to create a text view variable. So I'm going to say text view TV is equal to the text view version of this dot find view by ID r dot ID dot what do I call it? Title TV. All right. So what's happening here? This is an activity. So this is how an object refers to itself from within itself. So the keyword this is this particular instance of our activity. All activities know how to find a view given an ID inside themselves. They know where they're looking because we've set the content view of that guy. So if I'm the activity, if I'm this in this case, I have my content view sitting right here. And when somebody calls my find view by ID, if I think about this content view as kind of being a box of views, they give me an ID called title TV. I'm going to start rummaging through this box until I actually find the widget associated with that guy. And I'm going to return that widget as a generic view. Remember I mentioned a few minutes ago that anything you see on the screen is a view? I need this guy to actually be a text view. He's a little bit more than the generic view. Make sense? All right. So then I'm going to go ahead and say text view dot. Why is it not letting the... Let me kill Android Studio again real quick. I got that weird error a second ago saying it wasn't part of the project or something again. Does not belong to the project. Close that. Let me close that. Okay, seems like we're back in business. It was when they originally opened it, it had it like in a weird format. All right, so notice this guy's underlined right now because it doesn't know who text view is. So you can actually hit, let's see, on a, what's it going to be on a PC? Alt-Enter on a PC. So you just kind of put your mouse near, put your icon or the cursor near where it's at and hit Alt-Enter and it'll go ahead and import that text view guy up here. So there's my android.widget.textView. That way we have access to it. Just like historically we've imported java.util scanner to give us access to the scanner. All right, so now we know what a text view is. And I'm going to say tv.setText to blah. Okay, so we're seeing MVC in action here. I've given myself programmatic access to a widget that lives in my interface. And now I can use my variable that gives me access to that guy to do stuff to that widget. Make sense? So now when I launch this, when this activity is first created, right after we set the content view of that guy, we're going to go ahead and grab one of its text views and set the text of that particular text view to blah, overwriting whatever the text used to be. So I'll go ahead and launch this again. I wonder, is it trying to launch the second one? Okay, there we go. So there's my blah sitting there. Make sense? Okay, so that shows you how you can get those things to give yourself programmatic access to the stuff. Now let's look at maybe giving ourselves a button that reads something in from this text box. So let's go back out to our resource layout activity main. I'm going to go ahead and get rid of one of those guys there. going to call this guy input ET for the edit text for that guy. And then we're going to, for the input type for an edit text, you can choose a whole bunch of different things, and this will change what keyboard it brings up. All right, so we're just going to have it put in a just normal text. That's fine. Actually, we probably could just say none. And then it just becomes a generic edit text. Type whatever you want in there, we'll just deal with it. Okay, so I did that. And we want to go ahead and have that guy centered on there. I know this is really tiny for us right now. I'll hide this stuff here in a second. So I'm going to view all the properties. We're going to go down to gravity. And we'll say center. So now the text is centered in there. We'll hide that guy. So now we see the text is centered. Oh, it's because I have it hidden currently. So I'm going to go ahead and take the text out of that. But I'm going to add something here to hint. So hint is like placeholder text. So I'm going to say enter something like that. So now when we launch this, enter something will be sitting there, but that enter something will be, we won't have to delete it. When you type something, it'll immediately overwrite it, replace it. So this just gives you a hint of what we're looking for there. Okay. And then I'm going to go ahead and give myself a button. So we'll throw a button down here. All right. And I'm going to go ahead and we're going to organize this button. Let's put it below that guy. So now we're going to enter something. We maybe have our, actually let's put it below the linear layout but above our text view. So the idea is we'll enter something here, we'll hit the button, and the button will prove we received it right here. Make sense? Okay. So I'm going to change the button here. And we're going to change his text to click me. Okay. And we're going to set his width to wrap content so it's not too big. Now, see this guy is left justified right now. I'm going to go back to this vertical linear layout, the guy that houses these three things. So our vertical linear layout has within it our horizontal one, the button, and our title TV. So I'm going to go ahead and we're going to show more properties for that guy. We're going to go down to his gravity. And we're going to choose center. And notice that button just became centered. That button lives within that gravitational pull of his of the layout he lives within, which is this vertical one. And even though we didn't see these other guys move, because this guy takes up the whole width because he matches the width. So he is centered. He just has nowhere to go. This guy's centered. He just has nowhere to go. That makes sense? But this button, we chose for his width not to be the width of the parent. We chose his width to just wrap the click me word. And then we made it centered so that it would move to the center and not look weird. Kind of see how the gravity stuff is working? All right, so now we want to be able to hit the click me button, have it read in whatever's in here, and have it put the value here. That's what we want to happen. So let's go back to our code. Now, one issue we're going to have here, this comes down to our scoping, scoping rules. My variable named TV here, where do I have access to that guy? Don't get intimidated with the fact that we're dealing with a text view as opposed to a string. That's a variable named TV. Where does his scope live and die? Go ahead. Say this again. Find view by ID. This guy is a function that allowed us to find that guy. that guy ultimately returned the view that we captured inside of this variable. So I want to know where in my program right here do I have access to that variable. Let me give you an example. Do I have access to TV here? Why not? Okay, so this variable was created inside of the onCreate method. Therefore, his scope is local to this onCreate method and lives and dies with that. If I want to have access to that text view down here, what do I have to do? Okay, I could take it as a parameter. But we don't know who's going to call this guy yet. So let's say that's out of the question. So we're going to say taking it as a parameter isn't going to help us. So my goal, my option here is I need to make this variable available to this scope. How do I do that?
Find it in farther up scope.
Yeah, the more global scope. Go up to our more global scope, define our variable up there. So I'm going to say this guy right there, I'll define it up there. I can set it in here. So we can even say this.tv. I like to use this dot just as clarification, but it meant the same thing because we were coming from a non-static context there. So I define my variable up here between this opening curly brace and this closing curly brace, which means he's accessible anywhere in there, in all those places. He actually received his value here, but the scope of the variable was defined here. All right, I went to Target, I bought a plate, brought the plate home to my house. I actually put food on the plate in here. The plate's still available anywhere in my house. Okay? So now that I have that, I can now access that variable TV down in here. Okay? And what we're going to do is initially we're just going to say tv.setText button clicked. Like that. Okay? So what I'll do actually initially is I'll make the text of that text view nothing. So I'll make it empty so we wouldn't be able to see it initially. Then the goal is that when we click the button, that text view will update its text to say button clicked. Okay? I'm going to go ahead and copy this method because I want to see if they fix something. All right, so I'm going to copy that method there. Now, when we want to make on-click methods for our buttons, they have to match this. It's got to be public void. You can name the method whatever you want, but it has to take in a view v or a view whatever as a parameter. That view is the widget that was clicked that called this guy. All right. Now we got to go back over to our interface and let our interface know about this function. So this is again MVC, marrying the model view controller together. Okay. So we'll come back over here. We want something to happen when we click this button. And this guy has an on-click property right down here. All right, so I'm interested to see if they fix this. So when I hit this drop down here, notice that it knows about my button clicked. It sees that guy. This was broken before. It wasn't calling it correctly. So let's see if it calls it correctly now. Otherwise, I'll just show you. You actually just paste the code in there. Yeah, the problem was this main activity part that was in there. But let's see if it fixed it. So whenever we click that button, it's going to call this method. And that method does what that method does. All right, so before, I'll go ahead and put a 5 in here. Although it doesn't matter what I put in there. This would crash when I click that. Oh, no, they did fix it. Good for them. All right. That was 20 minutes of my life I'll never get back. In the middle of a grad class 2 weeks ago. All right, so you can select your method from there, and it'll, so now every time we click that guy, it'll say button clicked. Now what we really wanted to do is we really wanted to grab whatever is here and move it to here. Well, copy it to there, right? So we can see that those two are connected to each other. We can read in from this edit text and output to this text view. So we'll go back to our interface here. Here's our edit text. We need to get, okay, we called it input ET, so we already have a name for that guy. All right, so I need to go ahead and give myself access to this guy so I can read whatever text is in there and write the text down here. So I'll go back to my main activity. I'll go ahead and give myself an edit text ET. Or we can maybe call this guy input ET. And then we're going to go ahead and we're going to say this dot input ET is equal to the edit text version of this dot find view by ID r dot ID dot input ET. Okay? And it will go ahead and connect those. Now let me talk about this guy here for a second, the R class. The R class is kind of a, let's call it a Android hack. This is how Android provides this model view controller connectivity. Rather than us having to remember the exact ID of the code the widget we created, we can go and look that guy up by saying r.id.input.et. R is a class that Android continually rewrites. And inside that class, we have layouts, we have IDs, we have several different things. And we can actually hunt through here and find that class. Let's see. Where's it put that class? Gradle strips, maybe? He's somewhere in there. There's, at least there used to be a way to specifically get to it. It's not something you should change. Okay, it's a class that Android manages for us. And it keeps it updated with all of the widgets we've defined and that kind of stuff so that we can say, class, give me one of your IDs, specifically give me the ID named input ET. That make sense? Okay, so that's how we can look that stuff up. So now we have our input ET. So rather than saying button clicked here, we're going to set the text equal to this dot input.et.getText. So we'll get the text from that first guy. We'll write the text to our text view. So I'll go ahead and run this. So it says enter something, we'll put in a 5, we'll hit click me, and there's our 5. I'll put in a 7, we'll hit click me, there's our 7. So on and so forth. That makes some sense? Okay, so now, when you guys created a second activity, I know we're almost out of time, so let me just introduce something here real quick. When you guys created a second activity, you passed information from the first activity to the second activity through something called extras. So every single activity comes with its own little suitcase. Okay? And what you can do is as that activity is created, you can stuff a bunch of stuff in that suitcase that he can take with him. So that when he gets to that second screen, he can open up his suitcase and pull those values out. That makes some sense? What we're going to talk about next class is another design pattern known as the singleton design pattern. I want to say we talked about that last semester, right? Anybody remember what singleton is? It's a good idea to store things that need to be shared between more than two entities in a single place. So now you could say that tie goes to the runner in a situation where we have one activity that needs to pass a piece of information to a second activity. Maybe we use extras for that. It's like, hey, we got one more guy, I just need to get a piece of information to him. Do it in the extras, we're done. Now, what if you have 5 activities? They all need to share the same piece of information. Maybe the current user who's logged in or something like that. What we might choose to do is we might choose to put that information in a class that's accessible to all of them. Rather than passing that piece of information from activity to activity to activity, we might give ourselves the convenience of just putting it in one place. That makes sense? All right, so for Tuesday, go back through, now that you've seen me kind of do some of this stuff, go back through your tutorials, make sure you have a strong understanding of all the stuff we've done up to this point. We might have a quiz on Tuesday covering something I talked about in class today. So make sure you're comfortable with this stuff. No homework assignment other than that, just make sure you're comfortable with all the stuff so far. We'll talk about singletons on Tuesday. All right?